Today will be part 3 as we continue on with our Ender 3 journey. In this series of videos, we're taking the Ender 3 and we're stepping through it just like a new 3D printing user would. In the first video, we did the assembly. The second video, we did a few upgrades that fixed just a few minor annoying issues and added a few nice-to-have features. And in this video, we're going to take it even further. Now, in the last video, we did replace the Boden tube with some Capricorn tubing and swap out the couplers on the Hotends side and the extruder. I did leave you some notes in that video, but I wanted to address a few issues before we got started in this video. So let's take a look at that real quick. So in the last video, we did swap out to this Capricorn TL tube, but what I didn't know at that time is there's a couple of different sets that you can get that have Capricorn tube and new couplers for the extruder side and the Hotends side. There's a little cheaper version of this kit that I don't recommend you buy. I did purchase both and compare them, but you want to get the one that's directly from Capricorn. It is a little higher priced, but the couplers that they give you for both sides are much higher quality, and you're not going to get this tube moving around in that coupler at all. So if you're replacing this tube, save yourself some headache, buy this directly from Capricorn, and you're going to be a lot better off down the road. So now that we have our Boden tube and our coupler swapped out to a lot higher quality version, there's one other upgrade that I wanted to address in this video, and it's a simple one, but one I think that's well worth the money, and that's replacing the bed springs. I noticed when I did the ABS test, I took the bed to 100°C, that the springs got really weak after they were heated. So I suggest you get just a little bit higher quality spring. So these are the stock Ender 3 springs. I believe the wire on these is around 1.2 millimeters. But you can see there's not a whole lot of spring to them, and there's not a whole lot of travel. Well, after I heated these up, there was even less. So that wasn't going to do us any good. I recommend that you swap these out with the springs that have the flatter coils on them. They seem to work just a little bit better. Something like this. So you can see the coils are nice and flat. They have a lot more travel. They're quite a bit stiffer spring. You don't want to get crazy with how stiff the springs are, but this is going to keep your bed a lot more stable than that old spring will. Also, it being flat gives it a little more seat on the bed side and on the Y carriage side. So these are very inexpensive, and this upgrade definitely can't hurt anything. So this upgrade is super easy to do. We don't even need to take the bed off. We can just undo both the leveling wheels on the front side first, then move to the back side. So we'll spin these loose. Once those are loose, you can just lift up on this in a little bit, remove those springs, slide our new springs in, put our wheels back on, and then we can do the same for the back side. Now the spring on the back on this corner actually sets above that strain relief. It's a little bit harder to get off, but no big deal. You should be able to lift it off and fish it out of there. Like so, and then we can put our new spring back in. And then we can switch out the other side over here. And put our knobs back on. And we are done. Now before we go re-level the bed, because you will have to do that, we're going to tighten these knobs up quite a bit because we don't want the nozzle to contact our bed surface. So let's go ahead and tighten these up. I'd say you tighten them up until you have about 5 millimeters of that screw sticking out the other side of the knob. When we go to re-level, better off we bring the bed up to the nozzle rather than the nozzle crashing into the bed. So let's go ahead and re-level real quick. We'll turn the printer on. Let's go ahead and heat the bed. We'll just set it to 60. And let's auto home. And we'll disable the steppers so we can move the bed and the X carriage around manually. And now you've probably seen this a dozen times or so, but we're just going to move around to each corner of the bed with a piece of paper and bring the bed up to the nozzle. You want it to just touch the paper and then back it off just a bit, but we're going to go around to every corner a couple of times and get the bed nice and level. So I've been around the bed 3 or 4 times. We're pretty level. Let's go ahead and check the center just to make sure. And we're pretty good there as well. So we're level. Now this isn't that big a deal or this huge upgrade, but having this little tighter spring should give you just a little bit more granular adjustment, as well as keep it from shifting at all if that spring wasn't tight enough. Also, you should be able to print at just a little higher bed temp now if you need to. So that ends the upgrade portion of our video, and that might disappoint a few of you because we're not going to swap out a lot of parts today, but I don't want to upgrade anything else until we talk about slicer settings. You might go along thinking you have some sort of hardware issue, when that can probably be fixed with just a few tweaks inside the slicer. And I think the best way to learn how to use the slicer is to create a profile from the ground up, or at least from a good default. So that's what the rest of this video is going to be. And the first thing I recommend you do before you get into the slicer and start messing around is measure your filament. The more consistent your filament is in size, the better off you're going to be all the way around. And that's probably not as big an issue today as it was in the past, because there's a lot of consistent filament out there, but it never hurts to take some measurements. So let's walk through that real quick. So this is the filament we're going to be using today. This is PM brand silver. It usually is very consistent in size. It prints just a little higher temp than a lot of PLAs. 200 to 220 is what they recommend. We'll go over the temp setting here a little more in a minute. But also this color shows up really well on the camera, so I can show you what the layer heights look like during all of our testing. So to measure its size, we're just going to pull some out. And I like to measure 10 or so spots along about 3 meters long ways, and just see how consistent the filament is. So we have a 1.7 down here, we've got a 1.75 up here, 1.76, 1.74. Down here we have 1.74, 1.75. So there are a few dips in size, but nothing to be really concerned about. A tolerance of 0.05 is what most companies are shooting for nowadays. We really want it to be consistent with itself. I'll show you more of that in the slicer here in a minute. It'll make some more sense. But this tolerance probably doesn't matter a whole lot. Or even better still, if you have a micrometer, you can use that. The micrometer in this spot says we're setting at about 1.73. Now on to the slicer. I'm going to show you how to set up Prusa slicer, and there's a couple reasons for this. One, I prefer Prusa slicer. I've been using Prusa slicer / Slick3R since 2016. It's always been my go-to slicer, and I know how to use it the best. Also, there's a lot of tutorials about Cura out there and some great profiles already, so I thought maybe going through Prusa slicer step by step might be helpful. Also, considering some other slicers, this one is free of charge and Prusa is actively developing it. This is Prusa Slicer 2.1.1. So the great thing about Slick3R or Prusa Slicer is they have a pretty nice default configuration to start with. It does need a few tweaks, but just setting it up by default is going to get you pretty far at getting a pretty nice print. So that's what I recommend any new Prusa Slicer user does. Go up here to Configuration, go to Configuration Wizard, we'll just hit Next. If you have a Prusa machine, you can go ahead and select it here to get their profiles, but that's not our concern in this tutorial. We'll just hit Next. Don't need anything for the SL1. And then we come to Custom Printer. So let's click on Define a Custom Printer Profile, and let's call it Ender 3. And then we're just going to do some really quick settings. So we'll hit Next. We are using Marlin firmware. Go ahead and select that. Hit Next. Bed shape, we're going to do 220 by 220. We are going to alter the origin, but I'm going to show you that here in a little bit. Hit Next. We are using a 0.4 nozzle, so we'll leave that there, and we're using 1.75 millimeter filament. We are also going to cover this setting, the filament diameter, in the slicer here in just a minute. That's why we went through the whole filament measuring procedure. Let's hit Next. Extrusion tip, when you're starting to test and you're dialing in your slicer, you probably want to go on the low end of what your manufacturer suggests. When you go into the higher range, it has the possibility of magnifying some of the issues you might be trying to tweak in your slicer, such as over extrusion. So we're going to stay at 200 for now because that's what Filament PM suggested. And with PLA bed temp on an Ender 3, let's just set it to 60. 60 is on the high side for PLA, but that will also help us ensure that it's going to stick to the bed. So we'll hit Next. You can allow it to go ahead and check for updates, use built-in presets automatically, that's fine, we'll hit Finish. Now that's going to update our pull downs over here in print settings, Ender 3 all the way across. And I truly want to walk through this with you step by step. So we're not going to change anything. I'm just going to show you what you're going to get with a default slicer profile. And I usually don't print calibration cubes. I don't ever calibrate with them, but it is a really fast print that we can do in about 20 minutes, so I can show you many of them over time. So we'll just come up here to add an STL file. I made this 20-20-20 cube. We'll bring it in. Infill, we're just going to set it to 10. And that's the only setting change we're going to make. So we're going to slice it, and then we'll export the G-code out, and we'll start it under Ender 3. So I did preheat the printer so I could load some filament, but I wanted to show you what this G-code does so we can fix a few things down the road. I am going to be printing from Pronterface just so it's easier for me to show you a lot of these things. But let me just go ahead and hit print. The first thing you're going to notice is that it starts heating the bed and it leaves the extruder off. So by default, it's going to make you wait for that bed to get up to temp before it starts heating the extruder. I like to heat them both at once, and I'll show you how to make that change. But let's get this first print out, and then we'll get into the settings more in depth here in a minute. Now the print is getting ready to start. We definitely want to watch the first layer on this one. Since we altered the springs on the bed, we might have to adjust the level just a little bit, but we want to make sure there's the right amount of squish on that first layer because that can affect how your print looks as well. So it looks like our leveling went pretty well. That first layer looks pretty good, so let's go ahead and let it print. So I'm going to pause this print real quick because I want to show you something. So if you take a look at the first couple of layers, you'll know that infill pattern looks kind of strange. That's because by default, Prusa Slicer, if you're using a default setup, they use stars. Now that's probably not the most efficient infill or the fastest. We'll probably want to change that up, but I just wanted to give you an idea of what you're going to get if you try the default print settings. So now let's go ahead and resume and let it complete. And let's see how we did. Just for reference, that one took 13 minutes and 19 seconds. One thing to note, our current slicer settings turns on the heated bed, but it doesn't turn it off. So we're definitely going to have to update that. So here's our first print, and this thing came out pretty well. Some of the brim got stuck in the bottom of the part, but we can fix that. But as far as the finish goes, this thing is really impressive with just the default slicer settings. One thing to note is there's a lot of filament squished out here on the top. It looks like it's a little overstuffed, but we'll take a look at that as well. And this is what it looks like just under a relatively inexpensive USB microscope. You can see those layers are pretty consistent. They do look just a little bit squished, but if you look down the top of that, that's one of the edges. They're really nice and even. So we've got a great baseline here. So back into Prusa Slicer, we're already doing a pretty good job, but let's fix up a couple of things real quick. First, we definitely want to turn that bed off when we're done with the print. So let's go to Printer Settings, let's go to Custom G-Code, and our default in G-Code, we're already turning off the hot end, and we're homing X and disabling the motors, but let's go ahead and turn off that bed as well when the print's over. So remember, we are using Marlin firmware. We're just going to do an M140. That's to set bed temperature. We're just going to set it to S0 to turn it off. We can add a comment with a semicolon, turn bed off. Also, if you remember at the start of the print, we heat up the bed and then we heat up the hot end. Let's go ahead and make sure both of those kick off at the same time so we don't have to wait so long. So on the first line, we're going to add an M104 to set the hot end temperature. We need to do an S, and then we're going to do a bracket, and we're going to set it to the first underscore layer underscore temperature, and then a close bracket, and we can add a comment, semicolon, set hot end temp. One of the great things about Prusa Slicer is you can use a lot of the parameters inside the slicer as variables in your start, end, and layer change G-code, as well as the other ones. And most of the time, it's going to give you that parameter name if you go look at that setting. So if you jump over to Filament Settings, and you hover over this first layer temp, you can see that parameter name at the bottom, first underscore layer underscore temperature, and that's what we're using in our start G-code. That's a really handy thing to have. So let's go back to Printer Settings. We're going to do the same thing for our bed temperature, and that is an M140. And we'll do an S. Same type of deal, we're going to use the parameter for the first layer bed temp. Bracket, first underscore layer underscore bed underscore temperature. Close that bracket, semicolon, you can add a comment. Set bed temp. So that's good. That will set the temperature for the hot end and the bed, but we also want to wait until those temperatures are achieved before the print starts. So we need to add a couple more lines. The next line we're going to add is an M190. This will wait for the bed temperature to be reached, so we'll do an S, bracket. Again, we're just going to do first layer bed temperature. We can copy and paste so we don't have to type it in. And we'll do another semicolon, wait for bed temp. And the last one, we want to wait for the hot end temperature to be reached. So we'll do an M109, S, and we're going to wait for that first layer temperature. We'll just copy, paste, add a comment, wait for hot end temp. And that should allow the heating to start both for the hot end and the bed at the same time, so you don't have to wait so long. So we're good here, we can save. And let's head over and check out print settings for a bit. So our default infill was stars. I want to change that to grid because it's a little faster and it's just as strong. We don't need anything too fancy. Layer in perimeters, we're currently printing at a 3. That's not a very fine layer height. I'm going to knock that down to 2. And then on first layer height, if you're having issues with bed adhesion, you can make the first layer just a little bit taller to help you out. It's going to pump out a little bit more plastic, but we shouldn't really need that. So we're going to lower that down to 2 as well. For now, 3 vertical shelves, that'll be plenty strong. 3 top and bottom, that's enough so that you don't see any infill poking through, so that should be good as well. Some of these other settings we'll get into in a bit. I'm going to come down to skirt and brim. I want to do 3 loops of skirt. Skirt just allows you to prime the hot end well before you start the print, just to make sure that it's flowing correctly before you start your first layer. Also, I'm going to bring the distance of the skirt out from the object to about 10 millimeters, just to make sure it's far enough away from the print so we don't end up with any of that skirt on the bottom of our part. We really only need 1 layer of skirt on the first layer. We're good for support material for now. Speed, we'll leave that alone for now. We'll take a look at that a little later. And then advanced. Extrusion width is going to be a very important setting when you're fine-tuning in your prints. These are not actually the defaults in Prusa Slicer. These are just the ones that come in when you load that default profile. I'm going to set these back to the default. So to go back to the default, you can just push this lock, and that's going to take them back to where they were originally. Now the reason why I'm doing this is because I want to show you the effect of some of these settings. Notice this first layer setting. It's set at 200% to give you a little fatter first layer to help with bed adhesion. Probably not the best looking print that you're going to get out of that, but it might help if you're having issues. We're going to change that up in a bit. But what is the default extrusion width? Well, it's a little bit different for each one of these settings. If you hover over the default extrusion width, it's going to tell you that it derives it from the nozzle diameter, but it also tells you to check out perimeters. And if you hover over perimeters, it tells you that it takes the nozzle width and multiplies it by 1.125. And if we open up the calculator, you can take your nozzle diameter, 0.4, times 1.125, and that gives us a 0.45. But it's important to note that top solid infill and support material are not configured that way. So to start with our testing, we're going to go with default for now. In Prusa Slicer, all you have to do is hover over the box to check out the note to see how it's actually going to be configured. So since I'm pretty sure we're not going to need that extra fat first layer for adhesion, I'm going to delete the 200%. I'm just going to set it to 0. So it's going to be set the same for all the layers. So that's all the changes I want to save for now. We'll save. Now we've made a few changes, so I want to go ahead and run another test print. We're going to export this G-code again. We don't want to make too many changes in a row because we won't know what change actually affected the print. So let's go ahead and do another one. So we went ahead and started the print, but you'll notice this time we have the hot end and the bed heating up at the same time. Most printers have the power to support that, so there's really no reason not to do that. It will save you a little bit of time on startup. Our second cube is off and running. We'll check back when it's done. The print is done. You can see the bed has been turned off, so that in G-code setting worked correctly. Let's see how the print looks. So this side is the first print with the 0.3 layer height. This is the second print with the 0.2 layer height. The first print did have a little higher first layer, a 0.35. You can kind of see on the corners where it was just a little bit elephant foot. We don't have that issue on our second print, so that's been fixed. At the lower layer height, you can see a little bit of the inconsistency that the printer might have, but we can probably fix that as well. We still do see just a little bit of over extrusion on the top here. And here's the microscopic view of that second cube if you'd like to take a look. It's still looking pretty consistent. That edge looks pretty good. So we tweaked a few of the settings, and you could probably get a fairly decent print with just this profile, but we haven't even scratched the surface yet. And it's important to note that we're tuning the slicer profile like a new user might. They're going to get in, tweak a few settings, run a print, and see how it turns out. We're also tuning for PLA plastic, because that's the most common type of filament that a new user is going to use. So where do we go from here? Well, next there's 3 main things that I'm concerned with. The first one being E-steps. When someone says E-steps, they're referring to the number of steps the extruder motor has to turn to move 1 millimeter of filament. Then we have extrusion width. Extrusion width is the width of the line that the hot end is going to lay down on the bed. Then we have extrusion multiplier, not to be confused with extrusion width. The multiplier is just an adjustment of flow rate for the hot end, where extrusion width is the width of the line that's being laid down, how far it is from the next line, and then an adjusted flow rate based on those values. I'm going to do my best to try to explain how all these things work together, but let's get started with E-steps. Now you've probably seen this done 100 times already, but it is kind of important so we can get into some other things. Now we just want to tune the hardware part. We don't want it impacted by how hot the hot end is, or maybe if you have a nozzle jam. So I've heated up the hot end, I'm going to pull the filament out, and then I'm going to remove the PTFE tube, the Boden tube, from this coupler. And then we can put our filament back in, and then just pick a spot where it's nice and consistent. We'll put your ruler, we'll stretch out some filament, and as precisely as I can, I'm going to mark mine at 150 millimeters. So back in the prouder face, I want to extrude this as slowly as possible because it's going to be more accurate. It is kind of painful, but if you go into settings, you go into options, you can set how fast the manual feed rate is. I'm going to set mine to 50. That's pretty slow. And then I'm going to extrude 100 millimeters. After the extruding's done, we're going to remeasure. And if you remeasure, you can see that we are really close to the 50 millimeter mark. So the motor in the extruder is doing its job hardware-wise. And it's important to note that the consistency or the diameter of the filament isn't really going to impact this setting much unless the filament is way off. This is just the hardware side of things. We said we wanted 100 millimeters of filament, we got 100 millimeters of filament. That's all we really need to be concerned with E-steps. Back into primer face, if we take a look, our current E-step setting is set to 93. If you're doing this with G-code commands, you might want to consider running an M83 to set it to relative mode. But if you're using these buttons up here, that's going to assume that you're already in relative mode, so you should be okay. If you need to correct this, I'll put the math up on the screen. You're going to want to take your desired amount of filament, so that's 100, divide it by what you actually got. For the sake of this, let's just say you got 95. And with that result, you're going to multiply that by the current setting of E-steps, and that's going to give you your new E-step setting. Hopefully that makes sense with what I put on the screen, but for now we're going to go with 93. I think it's close enough. And I think that's where we're going to leave it today. I know I kind of stopped in the middle of getting everything set up, but there's a lot of information here to go over, and I want to make sure that I go over it in as much detail as possible. Plus, breaking it up into smaller videos, I think it makes it just a little bit easier to digest. So part 4 of this series will be coming out very soon, and we'll finish up a lot of this slicer setup. Hopefully you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below, and as always, thanks for watching.